Hi everyone, my name is Jia Hao and I'm collaborating with Jaren for this project. Our project is the motto of a gear-driven music box. So here is the ideation and inspiration of our project. Our initial concept was to create a mechanism where a hand crank drives a series of gears, which in turn would set another object in motion. At first, we thought of building a drawer operate this way, but after further discussion, we realized that designing a reliable sliding mechanism would be too complex, and it wasn't the focus. So that was the part shown in the picture here. So we then decide we should try something else. We revisited our approach and concluded that a gear-driven music box, shown in the picture here, um, would align much better with our vision. So that's how we ultimately decided to pursue the Music Box project. And here's the further ideation sketch of our project. You can see the corresponding part in our sketch and in the actual music box we want to build. And here's the task assignment of this project. Jaren is responsible for the main body part, and I am responsible for the mechanical parts of the model, which is rendered in the picture. And then let me show you the model displaying the software. And just a head up, Jaren had some issues with SolidWorks while we made the presentation, so he will be using Onshape for his part of the demo. But all our models were originally built in SolidWorks. So in this video, I want to demonstrate how to use the motion analysis function in SolidWorks. First, you open the motion analysis function and you switch from animation to motion analysis. Then you're supposed to mate the part that you want to apply the motion on. And here, the two gears are already mated. So the next step, I'm going to choose a motor. I want to choose this surface, which is connected to the crank, and apply the components in direction. And set a speed you want. The next step, you want to select a contact between the two gears. Make it steel dry and steel greasy as requested. Finally, you switch the timeline to 10 seconds, then it will work. You can also check different type of calculation here. You collect results and you select the proper category. For example, I'm going to choose the angular displacement here. I select this, and it shows you the angular displacement of this part. That's all for now. Thanks.
Our project was to build a music box that doubles as a storage container. The, par- the upper part of the assembly plays music when the handle is cranked, while the lower part of the assembly can be used as storage compartments. During the making of this project, I was responsible for making the main body of the music box, while my teammate handled the gears, handle, and the rotating wheel of the music box. The dimensions for the base of the main body measures 40 millimeters by 40 millimeters with a height of 115 millimeters. The top features a curved cylinder with an opening which provides cutouts on the top and back to provide a clearer view of the internal structure while enhancing the overall aesthetics of the design. The lower section is designed as a rectangular part with multiple compartments, making it suitable for storing various items. Holes were engraved to fit the axle, crank, and Lego piece on both sides of the main structure. Some challenges that I encountered during the design were determining an appropriate size of the top for the top opening to showcase the rotating wheel, and more notably, dealing with dimensional tolerances when designing the holes. My teammate and I repeatedly discussed the axle and Lego dimensions and made several adjustments to ensure the final product fits perfectly.
Hello everyone, my name is Jiao Hao, and I'm responsible for the mechanical components of the project. As you can see, the parts I worked on have been rendered in different kind of colors, which are the handles, uh, the gears, the axle, and the blue music cylinder. So let's take a close look at the connection. Um, in this hand-cranked music box, the components are connected through a series of mechanical mates, as shown here, uh, that define the motion transfer from the handle to the music cylinder, which you can see when I rotates the crank, the blue cylinder is actually moving. So, the handle here is mounted to the driving gear using the concentric mate combined with the lock mate, ensuring that the gear rotates rigidly with the handle without any axial movement. And then it's the driving gear and the driven gear. The driving gear engages the driven gear through a gear mate, which establishes the rotation between two gears. And then it's the connection between the driven gear and the axle. The driven gear is connected to the main axle through a concentric mate. So also a lock mate is applied so the gear and the axle rotates as a single rigid body. The axle itself is supported by the housing using the revolute mate allow free rotation. Let me show you more clearly. You can see it allows free rotation here. So on the opposite end, the music cylinder is fixed to the axle with another concentric mate and lock mate, ensuring that the cylinder rotates exactly with the axle. And together, oh, I'm sorry, 1 second. Together, these connections create a fully constrained motion chain. So when you turn on the handle, it rotates the gear, and the driving gear rotates the driven gear, and the driven gear um, drives the axle. The, the movement of the axle drives the movement of the blue cylinder. Let me show you this way. You can see the blue cylinder is actually moving through the green axle in the middle. And there are some challenges I've encountered while assembling these parts. First, determining the appropriate mechanical connections and constraints between different components is a challenge. I had to decide which kind of joints or mates would allow the model to function smoothly while keep everything securely in place. So here are the gears in the model. You can see it's a little bit complex, and you have to think of what kind of connection will make it work appropriately. The second, after completing the design, the physical assembly did not operate as smoothly as expected. To be more specific, there were issues with rotation. So that requires adjusting tolerances and dimensions in the original model. So I discussed with Jaren, and after several times of discussion and refining the design, we finally achieved a working prototype. So later on, I will show you the prototype in the printed model. Thanks.